Ever wondered how 5G always finds the strongest signal, even while you are moving, turning, or hiding behind buildings? Today we break down the secret SSB, CSI-RS, and the new radio beam management, the invisible handshake that makes 5G fast and reliable. Welcome back to the 5G RF feature series. In this episode, we'll unpack how SSB and CSI-RS work together to help 5G pick the best beam, improve coverage, and support massive MIMO. Massive MIMO give us highly directional beams, but narrow beams means the network must constantly know which beam is best for each UE. That's the job of beam management, handled by two key signals, SSB, which helps users discover the cell, and CSI-RS, which helps refine the beam during connected mode. SSB is the first signal a device hears from the G node B. It contains PSS, primary synchronization signal, SSS, secondary synchronization signal, and PBCH, physical broadcasting channel, everything needed for initial access. Each SSB is transmitted on a different beam direction. By sweeping SSBs, the G node B covers the entire sector. Your phone measures the RSRP of each SSB and reports which beam is strongest. That's how 5G finds the initial best beam. Once connected, the G node B needs more accurate channel information. That's where CSI-RS comes in. Unlike SSB, CSI-RS can be transmitted on very narrow beams and even scheduled adaptively. The UE measures CSI-RS and reports CSI parameters like PMI, RI, and CQI, helping the G node B choose the optimal beam and the MIMO layer configuration. CSI-RS brings precision beam tuning. Beam management has 4 steps. First, the G node B sweeps beams using SSB or CSI-RS. Second, the UE measures them. Third, the UE reports back the best beams. Last, the G node B selects and refines the beam pair. Downlink usually use SSB and CSI-RS, while uplink beams only on SRS or reciprocity in TDD systems. To summarize, SSB handles discovery using wide beams. CSI-RS handles optimization using narrow beams. Together, they let the G node B find the best beam at any moment. As the UE moves, SSB gives the initial beams, then CSI-RS continuously refines the choice. If you walk behind a bus or a building blocks the signal, CSI-RS measurements trigger beam switching, preventing drops and preserving high throughput. A few parameters help tune beam management performance. SSB periodically controls how fast new beams are discovered. CSI-RS offers periodic, semi-persistent, and periodic options depending on mobility and node. Beam failure recovery ensures that if a beam suddenly disappears, REG quickly requires a new one. Feel free to pause and read the details in the table. In short, SSB finds the initial best beam. CSI-RS fine-tunes that beam continuously. Together, they enable stable mobility, high throughput, and the performance we expect from 5G. If you found this helpful, check out the full playlist of the 3GPP 5G New Radio RF features series, and subscribe to support more 5G 6G RF content like this. Thanks for watching.